Welcome back. We're looking at Baronett's Logic, 3rd edition, Chapter 6, sections C through F. What we already looked at was how to identify the elements of a categorical syllogism, how to organize an argument into what's known as standard form for the categorical syllogism, and identify an argument's mood and figure. Now we move on to techniques for testing an argument for validity. Let's start with using Venn diagrams to test an argument for validity on the modern interpretation of the universal. Now remember, when we're dealing with a single categorical proposition, we're dealing with a proposition that relates two classes of thing to each other. In other words, we have two circles, and the diagram, when we complete it, reflects those two circles' relations to each other. Another way to put this is that our Venn diagrams tell us visually what the logical structure of a given proposition is. Notice in a categorical syllogism, we have three classes of thing. Remember, we have the subject class in the conclusion, which is the minor term. We have the predicate class in the conclusion, which is the major term. And then we have the term that's repeated in the premises, the middle term. So take a look in the lower right corner and you'll see that there are three circles, each of which reflects one of the classes in the syllogism. So the numbering may help you as you're working. When we work face-to-face and we're working diagrams on the board, I'll write numbers so that I can ask class members what area needs to be diagrammed or left alone. So you may decide that you want to do that yourself, but just know that this is a way for you to organize your thinking about the areas of overlap and the areas where there is no overlap. I say that largely because lots of times people get a little bit overwhelmed. It feels like a lot of clutter, those areas of overlap. So the numbering can help you keep things straight. So let's now move on to the process of diagramming. First, when you are diagramming a categorical syllogism, you will always only diagram the premises. Moreover, when you are diagramming a syllogism that has at least one universal proposition, diagram the universal premise first. The reason why will become clear later. Suffice it to say, you want to eliminate those areas that can't have any X in them. So if you get those dealt with first, you won't need to go back into them later if you inadvertently diagrammed an X where in fact there can't be any X. So diagram your universals first. Lastly, you will always only diagram one premise at a time. In other words, take a look on the left side at the A proposition, all PRM. So that would be, because it's all PRM, a major premise. Notice that area 6 is shaded. You might say, but wait a second, S is involved in that. You're shading S, but you're not supposed to. The sentence says all PRM. But remember, if you're if you're diagramming the sentence all PRM, you're diagramming the PM relationship as if the S isn't there. Same with the E proposition. No S or M. That's a minor premise. So take a look at the SM area of overlap. Notice that you shade areas 2 and 3 because you're saying in so shading that there can't be anything in the SM area overlap. The fact that a portion of the P circle is shaded is not relevant to the diagramming of that specific proposition. When you diagram particular propositions, you're going to get into potentially some trickiness. And what I mean by that is this. Take a look at the area of overlap designated by sections 3 and 4. Notice there is an X right on the line. The X right on the line designates that the sentence does not specify if the X that is a P and an M is also an S or not. So by putting the X on the line, you're saying the X may be in 4 but not in 3, or it may be in 3 but not in 4. This will be crucial depending on what the other premise is in determining the validity of the argument. Okay, so before moving on to this O proposition diagram, let me say a little bit more about the thought that I just left you with at the last slide, namely determining the validity of an argument. One of the really nice things about Venn diagrams is that they help you to focus on what a visually valid argument is. Now, I know that I shouldn't use that phrase visually valid, so let me try something else. When you diagram an argument that's valid, you show the validity when you diagram the premises. In other words, an argument that's valid is an argument whose conclusion appears or is made explicit when you diagram the premises. The conclusion is pregnant, if you will, in the premises, and it emerges, it becomes apparent when you diagram those premises. If, on the other hand, the argument is invalid, then your conclusion will not appear. It will either be obviously false or it will be possibly false. More on that in a little bit. For now, let's focus on the claim some S are not M. So what's the area where you want to put your X? You know what to do in an O proposition. An O proposition is diagrammed with an X in the area of S outside of M. But is the area of S outside of M inside or outside of the P overlap? In other words, does the X go in area 5 or area 6? Since the premise by itself doesn't tell us that, we put the X on the line. All right, let's try out our technique. Take a look at the top italicized argument in its original standard form and then abstracted to show its structure a little more clearly. The premises are: some designer drugs are addictive chemical substances, some illegal drugs are not designer drugs, so some illegal drugs are not addictive chemical substances. Notice that the subject of the conclusion in this case is illegal drugs, and that term has been replaced with a capital I just to make the structure more clear. And then addictive chemical substances is the noun phrase that is the major term that's replaced with A. And then the middle term, designer drugs, is replaced with D. What is the mood and figure of this argument? Well, we have a particular affirmative, a particular negative, and a particular negative. That's IOO, figure 1. Check your chart to make sure that you see what I've just said. Now let's take a look at the diagram. Since there are no universal premises, it doesn't matter which premise we diagram first. Let's just go in order. So take a look at the DA overlap. Some D are A. The X goes on the line that crosses sections 3 and 4. That's because we don't know if the D that is an A is or is not also an I. Next, let's look at the minor premise. Some I are not D. The area that we want to diagram is area 5 and 6. That's because we're looking to put an X in the area that is in I outside of D. Notice, however, we don't know if the I that is outside of D is also outside of A, so we put the X on the line. Now, let's look at the conclusion. Remember, you always only diagram your premises. The conclusion says, some I are not A. Maybe, but maybe not. Look at that X that straddles the line between areas 5 and 6. If the X were in if the X were in area 5, the conclusion would be true. If the X were in area 6, the conclusion would be false. Since the conclusion could be true but could be false, the argument is invalid. Remember, an argument is valid when, and only when, if the premises are true, the conclusion must also be true. Now let's take a look at another argument. This time we've got a different mood and figure. We have a particular affirmative, a universal affirmative, a particular affirmative, which means that our mood is I, A, I. The figure is 4. That's because the middle term, E, is in the predicate position and subject position of, respectively, the major and minor premises. Since we do have a universal premise in our argument, we're going to diagram the universal first. All E are L. That means that area 1 and area 4 are shaded. That tells us that whatever E's there may be, they're all dumped into the L category, namely, they'd all be in area 2 and 3. Next, some B are E. That's our major premise, but since it's a particular claim in an argument that includes a universal claim, we diagram it secondly. Some B are E. Notice where the X is. It's in area 3. Why? Because area 4 is unavailable. The area of overlap between B and E is the area where we must put an X in order to accurately reflect the claim some B are E. But notice that area 4 is not available. Shading designates that there is nowhere you can put anything. So the X must go into area 3. All right, we're done diagramming. Let's look at the conclusion. Some L are B. The area of overlap that reflects a true claim for this proposition is 3 or 6. And in fact, we have an X in area 3, so the argument is valid. Now remember the note that I put on the opening slide for Chapter 6. I mentioned that we would diagram on the universal interpretation and then immediately after the traditional. Then we would move on to the rules of the syllogism. It seems to me that that makes some sense since you're already thinking in terms of Venns. Okay, we know when we diagram a universal claim on the traditional interpretation of the universal, we assume a member of the subject class exists. So take a look at the left and the right diagrams. On the traditional interpretation, notice there's an X in the area of overlap between C and E and the area of overlap between T and E. In other words, there is an X in the area where the 3 circles intersect. That is reflective of the traditional interpretation. So the circled X just tells us that we're assuming a member of the subject class. Notice that in the right Venn diagram, there is no x for the same argument. Let's look at that argument. All C are E, all E are T, so some T are C. On the modern interpretation, this argument is invalid, and we'll see that it violates rule number 6. On the traditional interpretation, however, that's not the case. On the traditional interpretation, since we assume a member of the C class exists, we assume a member of the E class exists, it follows that some T are C. We'll see that when we get to the rules, that rule 6 is not violated. All right, so let's put this into practice, this being the traditional interpretation that assumes existential import for universal claims. So let's look at the modern interpretation of the argument, no V are C, all C are L, so some L are V. We can see that the argument is invalid. It's invalid because there is no X in the area of overlap between L and V. Now let's take a look at the traditional interpretation. No V are C tells us that the area of overlap between V and C is empty. In other words, you can't put anything there. But we do assume that there is at least one V, so there's an X on the line between the V area outside of and inside of the L category. Then we see all C are L, assumes a member of C exists, and there is an X in the LC overlap area because we've assumed a member of C exists. Nevertheless, the conclusion, some L are V, does not appear. Remember, the X that's on the the X that's on the line may or may not be in the area of overlap between L and V, or the area of overlap that reflects the L-V relationship in the affirmative for a particular claim. So the argument is invalid. It's invalid on both the modern and the traditional interpretation. One of the things that's interesting about distinguishing between the modern and the traditional interpretation of the universal is it tells us what sorts of restricted inferences we can make, similarly to those inferences we can make around the square of opposition or by limitation on the traditional interpretation. So we move on to the second of our two techniques to test an argument for validity. The rules of the syllogism tell us whether or not an argument is valid. If your syllogism passes or satisfies each of the rules, so passes the test of rules 1 through 6, the argument is valid. But if your argument fails on a rule, it can be rule 1, it can be rule 6, it can be rule 3, it doesn't matter. The moment an argument fails to meet a rule or satisfy a rule, the argument is invalid. If you put the two techniques together, you have, as long as you follow the instructions for diagramming a syllogism using the Venn diagram technique or using the rules of the syllogism, you will have an infallible way of determining whether or not an argument is valid. Let's look at each of the rules in turn. Rule number 1 tells us that the middle term must be distributed in at least one premise. It doesn't have to be distributed in both premises, but at least one. If the middle term is not distributed, the argument fails, and the fallacy is known as undistributed middle. Rule number 2 tells us if a term is distributed in the conclusion, it must be distributed in its corresponding premise. Notice that we're not told a term has to be distributed in the conclusion, only that if it is, it must also be distributed in its corresponding premise. Rule number 3 tells us that you can't have two negative premises. Rule number 4 and rule number 5 tell us, respectively, that an argument with a negative premise must have a negative conclusion, and vice versa. Lastly, rule number 6 is the rule on which an argument fails on the modern interpretation if you have two universal premises and a particular conclusion. Remember the example you saw just a few minutes ago where an argument had two universal premises and a particular conclusion, and since the universal premises did not assume existential import, was the modern interpretation, the argument failed. In the particular scenario we looked at, the argument failed on the traditional interpretation as well, but that doesn't mean that it has to. So when you're thinking about the rules, again, you might think in terms of using the rules in combination with the Venn diagrams or vice versa. Just remember to keep straight the difference between the modern and the traditional interpretation of the universal. The only rule where there is a difference between the traditional and the modern interpretation is Rule 6. All right, let's go ahead and practice. First, let's look at the mood and figure and determine what the argument structure is. IAI figure 3 tells us that we have a particular affirmative major premise, a universal affirmative minor premise, and a particular affirmative conclusion. Figure 3 tells us that the middle term is in the subject position of the major and the minor premises. All right, now consider that we're going to focus right now just on whether or not this argument meets and satisfies all the rules of the syllogism. Let's focus on the modern interpretation alone. So what do we have? We have the particular affirmative major premise. Figure 3 tells us that the middle term is in the subject position. So our major premise reads, sum MRP. The minor premise is a universal affirmative. Figure 3 tells us that the middle term is in the subject position. So our minor premise reads all MRS. And then the conclusion reads sum SRP. First, is the middle term distributed at least once? In the major premise, no terms are distributed. In the minor premise, the middle term is distributed, all MRS. So rule number 1 is satisfied. Rule number 2 reads, if a term is distributed in the conclusion, it must also be distributed in its corresponding premise. Remember, I propositions don't distribute either the subject class or the predicate class. So that means no term is distributed, so the rule doesn't apply. Move on to rule number 3. An argument can't have two negative premises. It does not. Both premises are affirmative. Rule number 3 is satisfied. That also means that rules 4 and 5 are satisfied. Remember, rules 4 and 5 say that if you have a negative premise, you must have a negative conclusion, and vice versa. Since both premises are affirmative, those two rules don't apply as well. Lastly, rule number 6 says if both premises are universal, the conclusion can't be particular. Well, one of our premises is universal, but only one. The other one is a particular. So, all 6 rules have been satisfied. The argument is valid. Don't forget our distribution shorthand. You learned this back in Chapter 5. When we're looking at individual propositions in a categorical syllogism, we're looking to see whether the subject class, regardless of whether we're talking about the major, the minor, or the middle term, is distributed or not. The same goes for the predicate class. Suppose you're looking at a syllogism in which the minor premise is a universal affirmative, and you're looking at figure 4. That would say all M are S. So the universal affirmative in this case would distribute the middle term, because the middle term occupies the subject position. On the other hand, because the minor term occupies the predicate position, it is not distributed. All right, we just covered sections C through F of Chapter 6. What you learned was how to diagram a categorical syllogism in the modern or traditional interpretation to test the argument for validity. You also learned the rules of the syllogism for both the modern and traditional interpretation. Of course, they're identical with one exception, namely Rule 6. What we'll move on to next is how we can work with ordinary language arguments, enthymemes, and sorites. In other words, how do we translate ordinary language arguments into standard form for the categorical syllogism? How do we complete incomplete arguments? And how do we reduce the number of terms in an argument with more than 3 terms?